All right, chemistry, let's look at number 3. So number 3 on the worksheet, use the data found in table 4 on page 38 to answer, or sorry, of the text to answer the following questions. Now, it turns out that for this particular problem, that table actually is on page 38, but just be aware that this set of worksheets is actually associated with a different edition of this book. It's the same book, just a different edition. So there may be there will be problems like this on these worksheets that ask you to refer to a particular table or a particular figure, and it'll give you a page number, but it's not exactly on that page. Just be aware it's going to be pretty darn close to that page. And you'll see that it obviously refers to the question when you get there. I think the furthest away from the given page that one of those things ends up being is like 10 pages, so within 10 pages. So that's just a heads up, okay? It's not like it's not there. It's just that this worksheet is actually associated with a slightly different edition, and that's the reason that the pages don't always match up, but it will always be the item that they describe, the table 4 or figure number, whatever they have to say. Anywho, getting into it, this is the table that they're referring to. So this is table 4. It's 2-4 because it's chapter 2 and it's table 4. Densities of some familiar materials. And so we have things like cork, butter, ice, sucrose, bone, diamond, copper, lead. These are solids, right, at room temperature. And then liquids, which are obviously liquids at room temperature: gasoline, ethyl alcohol, kerosene, turpentine, water, seawater, milk, and mercury. The only exception, seawater is typically measured at 15 degrees Celsius. That's not something you're going to be tested on, just throwing that out there. So this is the table that we're using. So in order to answer these questions, we're going to refer to this table. So A, if ice were denser than liquid at 0 degrees Celsius, which is not, liquid water is more dense than ice, right, solid water, would it float or sink in water? Okay, so as it occurs right now, when you have a body of water and it starts to freeze, ice becomes a solid up here at the top, at the surface, and it stays on the surface. Now, normal, like typical, or should I say more common solids, they will actually fall to the bottom of whatever body of water that is because they tend to be more dense than water when they're in that particular state. Ice, however, don't take my word for it. Let's look at some numbers here. Ice, however, right, 0.92 grams per cubic centimeter, as opposed to water, which is just under 1. Now, this is typical water. Supposedly pure water is 1.0. It's kind of the standard, the definition. But like typical water is going to be a little bit less than 1, whereas ice is actually a good chunk less than 1, right? 0.998 versus 0.92. And just so we can be clear, this little crosshash right here indicates that it's measured at 0 degrees Celsius. You know, nothing crazy in terms of temperature. But because ice, solid water, is less dense, okay, less dense than liquid water, that ice is going to float. But that's not what the question is. If ice were denser than liquid, which is not, we just showed looking at the table that it's not, but if it were denser than liquid, would it float or sink? From that, we should conclude that it would sink. B, water and kerosene do not dissolve readily into one another. It's kind of like, you know, very similar to mixing water and oil. They don't mix. If the two are mixed, they quickly separate into layers. Which liquid floats on top? So with this particular problem, we're looking at water and kerosene. So let's look over here at the liquids. Okay, we have kerosene coming in with a density of 0.82, and we have water 0.998. Okay, so this suggests that liquid water is more dense than kerosene. Liquid water is more dense than kerosene. And so what that suggests is that is that the kerosene would float. Okay, because the question is asking which one would float on top. The other liquids in Table 4 that do not dissolve in water are gasoline, turpentine, and mercury. Which of these liquids would settle to the bottom when mixed with water? Now, I hope you're getting used to using this information. We are going to be looking for, out of 3 options, gas, turpentine, and mercury, we're going to look for one that has a density that is greater than water. And right here we have water with a density of 0.998 grams per milliliter. So first let's find gasoline, 0.67. Okay, well that's much less than water, so that would float. That's not what I want. Turpentine is the next option, 0.87. Again, much less than 0.998, so that would float. Down here to mercury, the last one, significantly larger than 1.0, 13.6 grams per milliliter, which makes it significantly more dense than water. And so back to the question, which of these would settle to the bottom? Mercury. And so this problem is basically forcing us to use data from a data table to answer questions.